Hello everyone, you're welcome to today's lesson on Maths with Ella. Today we are going to be looking at numerical methods, and the reason for this topic is because one of our followers commented that he had problems with numerical methods, and as we promised, we are here to help you achieve your desired grade in mathematics. So here we are today with numerical methods, and today we are going to be looking at the Newton-Raphson method. So the Newton-Raphson method is used to approximate the root to an equation, and the general formula of the Newton-Raphson method is given as we have here in this rectangular box. We have xn plus 1 being equal to xn minus f of xn of on f prime of xn. So going by this formula, we'll see that you need to have a good mastery of differentiation, because whatever function you're given, you have to find the first derivative of that function, that is f prime, as we have here in the formula. And also you should be able to evaluate a function at a point, because you're going to evaluate f at the point xn and f prime at the point xn. So that being said, let us see how we can apply this formula. When we have an equation and we are given maybe the first approximate root or solution to that function, we can get the other approximations to the root of that equation using this formula. That is, if we have maybe the first one, which is x1, if we are given the first approximation x1, then we can get x2, x3, x4 up to xn using this formula. So if we have x1, then in order to get x2, we are just going to have here x, this to be 1 plus 1, since our first approximation n is 1, being equal to x1 minus f of x1 on f prime of x1. In this way, we are going to have x2. Using x2, we can obtain x3. That will be x2 plus 1, which of course will be x2 minus f of x2 on f prime on x2, and so on until we get the required precision of approximation which the question requires from us. And so this is how we can use the Newton-Raphson method to approximate the solution or the root to an equation. Now let us illustrate this using an example. So we have here the first example, example 1, which I should mention here was it's a GCE question, GCE 2022 question 10, Roman 2, and the B section says, suppose we are given a function f such that r maps onto r, and the function is defined by f of x equal to 2x cubed plus 3x minus 2. That's our function, and we are asked to deduce that the equation has a root within the interval 0 and 1. The next part, taking x equals 0.5 as the first approximation to the root of the equation f of x equals 0, use Newton-Raphson's method once to obtain a second approximation to the root of this equation, and we are asked to give our answer to 2 decimal places. So let us solve this GCE question to illustrate how we can use the Newton-Raphson method to approximate the solution or the root of an equation. So here we have solution. First thing, the first part of the question asks us to deduce that equation has a root within the interval 0 and 1. So first thing, we write our equation, which is 2x cubed plus 3x minus 2. And we want to show that it has a root between 0 and 1. So the first thing is we evaluate f at the point 0, evaluate f at the point 1, and when we notice a change of sign, then we conclude that there exists a root in this interval. That is, first of all, we have f of 0, evaluate f at the point 0, that would be 2 into 0 cubed plus 3 into 0 minus 2, and that's going to give us negative 2. Now we evaluate f at the point 1, we're going to have 2 into 1 cube plus 3 into 1 minus 2. And this is going to give us, this is 2 plus 3, 5 minus 2, and this is 3. So we notice that f of 0 is negative, it's less than 0, and f of 1 is positive, is greater than 0. So we conclude that there exists a root of equation f of x in the interval 0 and 1. So that's how we can show that there exists a root between an interval. We evaluate the function at the endpoints of that interval, and if you notice a change in the sign, that is, one is negative and one is positive, then it's enough for us to conclude that there exists a root to that equation in that given interval. Now the next part of the question is we have been given x being 0.5, and we have been asked to use as the first approximation to the root of our equation f of x. Now we have to use the Newton-Raphson method once to find the second approximation. So first thing is to recall our formula. The Newton-Raphson formula, xn plus 1 is equal to xn minus f at xn divided by f prime at xn. So looking at this formula, we need xn, we need f at xn, and we need f prime at xn. Xn in this case is what we've been given. We've been given the first approximation. So we've been given the first approximation, that is x1 as 0.5. So the question says let us take x1 as 0.5, the first approximation. And we are looking for the second approximation. So we are looking for x2. We are looking for x2. So going by this formula, x2, because 1 plus 1 is 2, will be equal to x1, our n, in this case, is 1, minus f at x1, all this over x prime at x1. So we have x1, we need to find f at x1 and f prime at x1. Now the next things we need for this question, we need to find f prime of x first of all, before we can have f prime at x1. So we call this is our f of x, sorry. We need to differentiate this to find f prime of x, and that's going to give us, going by differentiation rules, we are going to have 6x squared minus 3. I hope we are okay with the differentiation, because that is a prerequisite for this lesson. You should be able to differentiate different kinds of functions. So differentiating this, so you bring down this power and then you subtract 1 from the power. That will give us 2 times 3, that gives us 6, and then x, 3 minus 1, that's 2 minus, the power here is 1, you bring down the 1 times 3, is going to give us 3x, 1 minus 1 is 0, so x to 0 is 1, so we are left with 6x squared minus 3. So at this level, we just have to evaluate. So we need to do f of 0.5. That's why f of x1, because our x1 is 0.5. So f of 0.5, we substitute 0.5 into our function f, into this function f that we're given. We're going to have 2 into 0.5 cube plus 3 into 0.5 minus 2. Punching this on your calculator, you're going to have negative 0.25. So we've gotten this, and now the next thing we need for our formula is f prime of x1. Our x1 is 0.5, so we have 0.5 here. F prime, now we're using this function because this is our function f prime. So this will be 6 into 0.5 squared minus 3. Again, punching this on your calculator, we obtain 4.5. So now we've obtained everything that we need for this formula in order to get x2. We have x1, which is 0.5. We have f of x1, which is negative 0.25. We have f prime of x1, which is 4.5. So now we can obtain x2, and x2 now would be, so therefore x2 will be equal to x1, which is 0.5, this x1, minus f at x1 that is negative 0.25 on f prime at x1 that will be 4.5, and punching this on your calculator we are going to obtain 0.56 to 2 decimal places as indicated in the question. So this is our second approximation to that question, to our function f of x given to 2 decimal places as required. So that's how we can use the Newton-Raphson method to approximate the root to an equation. I hope you understood the lesson, and if you have any questions, any doubts, or any worries, please do not hesitate to reach out to us. Drop your comments and your worries in the comment section, and we will get back to you. Thank you so much for watching, and until we come your way again, remain blessed.